Now in the search part, I will be opening the Chrome extension and I'll make a query. Like here I'll make a query, when was Sai Baba born. So here the query, it goes to the backend, it makes a search in the vector embeddings, then it makes a RAG search, and then calls the LLM and get the final answer. So this is the final answer. So this is coming from the vector search using RAG and calling the LLM. I'll explain the code later. Now if I go to this part, so this is right, like 1838, the answer given was right. Now if I ask the next query, what is nomic embedding, so it has also given the right answer and it is also giving the URL also. So once I open this thing, so the right URL is getting opened and this text, it is coming as answer. Okay. Now I'll explain the code. So in the code, we have the fast API search. So request comes over here, and then it makes a call to the agent.py. Agent.py, we have MCP server, which is we have a two type of MCP server generally, but here we have used stdio, which is basically a session based, not stateless. SSE is a stateless, so we are creating an instance of a stdio server client session we are starting, and then we are finding what are the tools that are available. So whatever the tools that are available inside the MCP server, so these are the tools that are available. So wherever the method is attributed with the at that mcp.tools, so those will be listed here. So those will be listed here, and once we get the list of the tool, we are creating an instance of a memory manager, then creating the session ID, okay, and then we are making a call to the LLM. So first call goes to the perception. So perception is a basic input, user input, as well as the what are the different tools that are available, along with the session ID, all the things we are sending to the Gemini LLM. So this perception layer we are calling, and then we will get a output what needs to be done for the as part of the next step. So so based on this thing, what are the steps needs to be done for the next step. We are making a call to the decision. What are the decision needs to be taken? So as part of the decision, we are sending the initial report by the LLM based on the query that we receive from the user, and list of the tools that are available, and it goes to decision.py, and here basically all decision is happening by the LLM, and this is a long prompt over here, and lot of instruction we are giving. And if suppose it is an arithmetic call, then it should be a function call. Then if it is like a something if it is like A and B, we are telling add, so we should call the add function. Similarly, if there is a something we need to search from the based on the query, we need to search from the vector DB, something like, then we call the specific method call as a search document, and whenever we get a final answer in form of a list which is having the description as well as the URL from where the embeddings are generated. So based on this decision given by the LLM, we make a tool call. So from once we get the response from the decision, we are making based on the based on the output. If it is a final answer, we are sending the directly to response directly to the first API. If it is not a final answer, if it is a function call, we are making a tool call over here. So it comes to this part of the code, and we are making an execute tool, and then this execute tool, it will come here. Then we make a call to the tool. So tool calling is nothing but calling to the MCP server. Okay. So here in this case, we make a call to the search document. So what we are doing is we are looking into the, based on the user query, we are searching into the vector store, and based on the input from the vector store, we are generating a context, and that context along with the prompt, we are passing to the LLM to generate the answer, to generate the final answer. So we are not only searching in the vector DB, but we are passing those answer that we retrieve from the vector DB in form of a context to LLM to get more precise answer and to avoid the hallucination problem. And finally, this answer, it is in the form of list. So so the long description along with the URL will come as part of this answer. So it will be like something like the answer will come here, and then this URL will come here. So that instruction also we are giving to LLM, and once we get the result, it will come to this agent.py, and we find that okay, this is the final answer, and that is a response from the LLM, and then we break the loop, and the session, and we tell okay, we are logging next agent session is completed. We give the response back to the first API. So this is how the overall flow of the first API. So as part of the additional implements, we have done two things. One is in the search document, after retrieving the data from the files vector store, we are making a RAG call. We are implemented RAG, retrieval augmented generation. So those context, whatever we received, we are sending to the LLM again, based on that thing, we are generating the output. So it's a very not so much like advanced or form of a RAG implementation. It's like just to demonstrate, like to work on with the agent. So as we progress, so we'll modify this part of the code, like how we can modify the retrievers and other things. So that thing we definitely will implement different type of retrievers also over here. And second modification, second enhancement, what we have done is like we initially started with for the indexing with a fast API server, where as we browse across the different tabs, we were basically receiving the HTML data, but the problem is that if you make a very fast movement across the tab, the call was getting dropped. So how to handle that thing? So I need to implement some sort of a queuing mechanism, and initially I thought with let's say like Kafka or something like, but since it is a very like low, I mean it's not like such a heavy duty implementation, so that's why like we started with a Redis. So Redis has like queue inbuilt with that, so that we have leveraged. So whatever that input we are getting, we are queuing those input. Okay, and then once we queue those input, there is one more. So here we are basically making the queue of the input, right? And we are telling we need to call to the MCP. So we need to call to the MCP call tool, and what are the arguments that we need to call. We are telling okay, this method needs to be called, like process HTML or process document, whatever element is we need to call, and in some cases we need to pass the argument also. So those also we are passing there, but this thing will be put in the queue. So there is one more Redis job that is running, which will be responsible for. So basically there will be one more jobs that are running. So this is a Redis job, which are running, which will be running, and it will be taking the item which I have added in the queue in the first API, in the first API. So whatever I have added in the queue, whatever I have added in this queue, so there is a job that is running, and that job will basically make a call. And here we have defined which function to be called and what are the arguments to be passed. So those all the things are stacked inside the queue, and it will make a call to the MCP. So we are basically disconnecting between fast API and MCP, or rather, and we are putting a queue over there, so that like if the user is moving a very fast across the browser in different tabs of a browser, so the data will not be lost. It will be preserved in the queue, and it will be processed sequentially. So these are the two enhancements that I have done over here, and that I will put in the readme file also. Thank you.